Good morning, good morning, good morning.
I am Groot.
I have a quick little video here. It's Mr. Yago going through Lewis structures for covalent bonds. So this is a little bit different process than we dealt with in ionics. I have an example here. We're going to take carbon and we are going to combine it with oxygen. So carbon being combined with oxygen. So usual things apply. You're going to start to get in a habit of figuring out what your exact central atom is going to be. In this case, we always start with the first one that's given. So I'm going to start with carbon. Carbon has 4 valence electrons because it's in group 14. Now, oxygen, on the other hand, is in group 16. It has 6 valence electrons. So I'm just going to kind of make this a little easier. I'm going to go like that. So essentially what this is going to look like is we have the ability to make 4 bonds. This is the ability to make 2 bonds. So although I've drawn this dot structure out, it's going to get a little crazy. So I don't mean to cause any alarm, but I'm going to actually undo this. Because when you draw a bond, you have to draw a line, okay? So that would look like this, and that would look like this. This line is a shared electron. Nothing's getting donated. It's a shared electron. So technically one line, I'll put that right here, one line equals 2 electrons. Okay. Now, if we take a look and if you watch where I'm going to trace here, oxygen now has 2, 4, 6, 8. It's happy. Carbon, on the other hand, has 2, 4, 5, 6. So you count this line for both the carbon and you count this line both for the oxygen because it is shared. So this means that we unfortunately have to draw another oxygen. So as you can see here, this would then connect across, this would then connect across, and it looks a little messy. So I'm going to redo it here and show you what it's going to look like. And you can kind of start to figure out what it should look like based off of the amount of valence electrons. So if you take a look now, oxygen's happy. Carbon now has 2, 4, 6, 8 because those lines are shared. So what I'm going to do is I'm going to back up here. And I am just going to show you what a clean representation of this would look like, just because I kind of know already after drawing these. So what I would do is I'd put carbon here. I know that because carbon has 4 to offer and oxygen has 2 spots available, a least common multiple of 2 and 4 would be 4. So I'm going to draw oxygen over here. I'm going to actually put 2 dots here, 2 dots here, 2 dots here, and maybe some of you are starting to see what I'm doing here. I'm going to go like this. I'm going to go like this. Now this is nice and clean. Okay, I kind of predicted what I need to do, and you'll get good at this. But that way you can see a beautiful arrangement of carbon and oxygen. Right over here we got lone pairs. But if we were to draw what this would look like in terms of who receives what electrons, I'm just going to kind of like go like this. So if we look at what oxygen has, oxygen is going to get 1, 2, 3, 4, right? Because there's 2 for each line. 5, 6, 7, 8. It's happy. The oxygen over here, oxygen has 1, 2, 3, 4, 5, 6, 7, 8. It's happy. And then if we look at carbon in the middle, carbon is got a lot to work with here. I'm just going to take a different color. Carbon has 2, 4, 6, 8. So all of them are getting their valence electrons. This is a nice clean look. The formula for this would then be CO2. We can see that right there. So big things to remember is the line represents 2 electrons. Electrons are being shared. Nothing is donated. These are 2 non-metals that we're working with. So hopefully that helps you and assists you with going through this process. If you have any questions, as always, take a second and talk to your science teacher and figure it out.